Good morning friends. Today I am going to explain one of the important topic in ray optics, that is Snell's law, and this is very important for the class 12 students. Generally the question will be coming: define Snell's law using a neat labeled diagram, derive an expression for refractive index of the material of an equilateral prism. So for that purpose, first of all I will give the definition for this one. What is Snell's law? That is the ratio of the sine of the angle of incidence to the sine of the angle of refraction is constant, called the refractive index of the medium. Simply, sine I by sine r is equal to some constant, that is known as the Snell's law. Here I is the angle of incidence and next r is the angle of refraction. Now our aim is we are to derive the refractive index of the material of an equilateral prism. For that purpose, let us consider ABC is a one equilateral prism of angle A. Here, let ABC be the glass prism of angle A and refractive index of the prism is mu. Let us suppose this is equilateral, means yours each angle will be 60 degrees and the refractive index of this prism is mu. Let a ray of light PQ be incident on the face AB. It is refracted into the prism along QR and strike the second face AC at R. So let us suppose PQ is a light ray which is incident on the face AB face. Now when this instant strike or instant on strikes the face, so the refracted part is goes as QR and emerges out as RS. Okay, now here we have to consider the emergent ray is RS is produced in the backward direction. Here we are producing the RS is in the backward direction. These dotted lines are representation of we are only producing this RS in the backward direction. The incident ray PQ would have traveled along PQTX in the absence of the prism. Now imagine there is no prism. So then that time the right ray will be travel as PQTX. Here traveling along PQTX in the absence of the prism. So now let I1 be the angle of incidence and I2 be the angle of emergence and R1 R2 be the angles of refraction and D is the angle of deviation. Here we have to consider the situation, that is here this one angle of incidence and this is angle of refraction, angle of incidence I1 and I2 is the angle of emergence. Next R1 and R2 are the two angle of refraction. Here the angle D, so this is known as the angle of deviation. Now we have to consider the triangle, this one QRO. So to calculate the refractive index of the material, we have to consider first of all the triangle QRO. So by this we know by the properties of the triangle, this three angles will be equal to 180 degrees. So we can write R1 plus R2 plus angle O is equal to the 180 degrees, and let us take this is equation number 1. Okay, from quadrilateral we can write this quadrilateral AQORA. Here we have to consider the quadrilateral AQORA. By that we can write angle A plus angle O is equal to 180 degrees. So we can write from the quadrilateral sorry, equateral AQOR angle A plus angle O is equal to 180 degrees. So by the properties of quadrilateral. So first of all, what we have considered, that is just simply QRO angles. So by the property of this angles, that is R1 plus R2 plus O angle will be equal to 180 degrees. That is equation number 1. And next we have to consider the quadrilateral, that is AQOR A, like this. So that time by the property of the quadrilateral, angle A plus angle O is equal to the 180 degrees. Now I can write angle O is equal to 180 degrees minus A. Okay, let us take, this is equation number 1. Now we can substitute the value of O in the equation number 1, or we can write from equations 1 and 2 we get R1 plus R2 plus O is equal to 180 degrees. This is equation number 1. So in place of O, I am going to substitute the value of R1 plus R2 plus O value is 180 degrees minus A, and this is equal to the 180 degrees. So both the sides equal 180 degrees get cancelled. We will get R1 plus R2 is equal to the A. Now let us take, this is equation number 3. Okay. Now from the triangle TQR, from TQR, now consider the situation TQR, we can write this will be equal to, and first we will write for the deviation angle is equal to the angle TQR plus angle TRQ, and this is take the fourth equation, and this is nothing but it's by the property of exterior angle is equal to the interior angle. To the sum of the interior opposite angles. Only this is a note to understand the concept. Here we have considered D. What is this D value? Angle of deviation is equal to the TQR is equal to the TQR plus TRQ. So this is one of the property. So next, first of all we have to calculate for the TQR value, can be written as TQO minus OQR. So this can be written as here TQR is equal to the TQO minus OQR. But we know that TQO is equal to the PQN, and that is equal to the I1. Here this one TQO is equal to the PQN, this is equal to the PQN. So the value of this PQN is equal to the I1, and this TQR O both are equal. So that's why we can write TQO is equal to PQN is equal to I1. Okay, so therefore TQR is equal to, so this TQO value we got I1, and OQR here. OQR can be written as R1. So we can let R1. Okay. So let us take this is equation number 5. Similarly, we can write, or we will get, for TRQ. TRQ is equal to I2 minus R2, and this is equation number 6. Here first of all we have to calculate the first of all we have to consider the angle of deviation, that is equal to TQR plus TRQ. This is nothing but the angle of deviation. Now we are using the properties, that is exterior angle equal to the sum of the interior opposite angles. So here TQR is equal to TQO minus OQR, and next TQO is equal to PQN is equal to I1, and TQR is equal to I1 minus R1, and this is equation number 5, and this is equation number 6. Now we are going to use this equation number 5 and 6 in 4, using equation numbers 5 and 6 in 4. So just simply substituting the value of TQR and TRQ in equation number 4. When you substitute this value, then we will get the angle of deviation is equal to I1 minus R1 plus I2 minus R2. Now D is equal to the I1 plus I2 and minus, if you take out common, minus R1 plus R2. Now we know that, or since R1 plus R2 is equal to the A. Okay, so here R1 plus R2 is equal to the angle of the prism A. So this can be written as D is equal to I1 plus I2 minus A. Okay, so now I am going to explain a little bit minimum deviation position. It is experimentally found that as the angle of incidence is increases, angle of deviation is decreases. So in your practicals might be you have done this one to calculate the minimum deviation. This is DM O, angle of incidence is in this direction, x axis, and this one is y axis. Now these here. So here it is experimentally proved that angle of incidence is increases, angle of deviation is decreases. Incidence is increases, deviation is decreases, and it reaches a minimum position, and again it is increasing. So at minimum position the two angle of incidence are same. At this minimum position, these two I1 plus I2 is I1 is equal to I2. So that is at minimum deviation position I1 is equal to I2, and also angle of refraction also same. At this minimum deviation position angle of refractions also same. So we are going to use this property. Now equation 3 can be written as, now equation 3 can be written as, so what is the equation 3 they have? R1 plus R2 is equal to A. R1 plus R2 is equal to the A. This was the equation number 3. So in this we are substituting, just now I told you at minimum deviation R1 is equal to R2. So that's why in place of R1 R2 we are substituting the value of R1. R1 is equal to the A, or we can write 2R1 is equal to the A. Now, or we can write R1 is equal to A by 2, and this is, let us take equation number 8. Now, equation number 7 can be written as, so now what is the equation number 7? Now first I will tell you. Equation 7, sorry, where is that equation? 5, 6, yeah, this one is equation number 7. That is D is equal to I1 plus I2 minus A. So this can be written as D is equal to I1 plus I2 minus A. This is equation 7. So at minimum deviation position, I1 plus I2 minus A. So we know that at minimum deviation position, I1 is equal to I2. So that's why I1 plus I2 minus A, or we can write A plus dm is equal to 2, A plus dm is equal to 2 I1, or I1 is equal to A plus dm by 2. Now let us take this is equation number 9. Sorry. Now, according to the Snell's law, applying this Snell's law at point QR, mu is equal to the sine I by I1 by sine R1, and this can be written as sine I2 by sine R2, and this is take equation number 10. Now using equations 8 and 9 in 10, we get, so equation number 8 and 9. Here R1 is equal to A by 2 and 9 is I1 is equal to A plus dm by 2. So just simply, and this is equation number 10. So when you substitute these equations in equation number 10, we will get the expression for the refractive index, that is sine A plus dm by 2 by sine A by 2. So this is the expression for the refractive index of the given material. For more videos, subscribe my channel Physics. Thank you.